So here we want to solve 2 ln of x is ln of 2x plus 3. So as you can see, we have logarithms on both sides here, okay? And implicitly, I can see that x will have to be positive in my final answer, and 2x plus 3 will have to be positive. But like I said, it's easier just to try to solve it, and whatever answer you get, you replace it into the equation, and that's going to verify two things: whether the logarithms are all defined, okay? And you're just going to also check that the solution you have does indeed satisfy the equation. So the idea here is to end up with logarithms of something on both sides so that we can use the one-to-one property of logarithms. So I've got this 2 that's sort of in the way. Now if I send it on the other side, it's not helping me because then it would just be in front of the other logarithm. So this is not a viable solution. How do I get rid of the 2, or how do I make sure that it's not in front of my logarithm? Well, you'll just have to remember that this constant here, or this expression, it can be brought as an exponent of the argument of the logarithm. So instead of 2 ln of x, it's ln of x squared. And then this side, I don't need to do anything else. But if I had like a 3 there, I would also send it as an exponent, okay? Or any other type of expression. And now I've got logs of something, a log of something equal log of something else. So those arguments, the x squared and the 2x plus 3, okay, must be equal. And then I end up with a quadratic equation, which is a little bit different than what we had before. We would always end up with linear equation, but this linear equations, but here it's a quadratic equation. So I can try to factor that using the AC method. So the product of -3, sum of -2. So that's -3 and 1. So I end up with x equals to 3 or x equals to -1. So this is where I have to verify that my solutions actually work. So here, so let's verify if they work. Okay, so this is where you replace x by 3, so you calculate 2 ln of 3. That's okay, you can calculate that. And then you calculate ln of 2 times 3 plus 3, so that's ln of 6 plus 3, 9. Okay, and I'm not going to even use my calculator here. Ln of 2 times 3, I can bring the 2 in front as an exponent. This is ln of 3 squared. This is ln of 9. So as you can see, they're equal. So this is testing x equals to 3. X equals to 3 works. X equals -1. If I look at the left-hand side, it's going to be 2 ln of -1. And this is where, okay, you get something that's undefined. Okay, maybe I should write it fully, is undefined. So this is not a valid solution. So the only solution would be x equals to 3. Okay, problem came from this first step, okay? So by sending the 2 as an exponent, we got ln of x squared, and all of a sudden, for x squared, it's okay to replace x by -1. So if you replace x by -1 in the second like in this equation here, we get ln of 1, or -1 squared, okay, which is ln of 1. And on the other side, we get ln of -2 plus 3, which is ln of 1. So you see you get ln of 1 on both sides. So it satisfies, -1 would satisfy this equation, but it doesn't satisfy this one, okay? So here, everything's equivalent, okay? All of these are equivalent, okay? But it's here where, so all of these are equivalent, but from going from the first to the second equation is just an implication. It doesn't go the other way around. Because the domain of the logarithmic functions have changed by sending the 2 as an exponent. So I wanted to show an example where you have to verify your answers and one of them doesn't actually work.